welcome to Data Science Pills, the YouTube channel to get you started in your data science journey. So, today I'm going to be talking about univariate analysis in R. Just for a bit of context, univariate analysis is the analysis of a single variable, without taking into account its relationship with other variables. It's the simplest form of analysis you can do, and it's often used to kind of just summarize and find patterns in the data, and to also get a grasp of the data you're analyzing. There's two forms of univariate analysis. There are the numerical descriptive techniques, all around numbers, and the graphical descriptive techniques. And as the name says, it's all about graphs, it's about pie charts and histograms, and how to visually understand your data. So today we're going to be focusing on the numerical descriptive techniques and how to do them in R. The numerical descriptive techniques can be grouped in two groups. The measures of central tendency, such as the mean and the median and the mode, that help us understand where the data is centered around, and also the measures of variability, such as the variance, the standard deviation, and interquartile range, that will help us understand how dispersed our data is. Okay? So having said this, let's get started. So let's start with univariate analysis in R. So the first thing you're going to have to do is just create one of these R scripts or a Markdown. In order to do so, just come here and create one. And then I also recommend whenever you start a project to make sure that you're on the working directory, and the working directory is this one. So if you, it's here. So if you go into these three dots here, you'll be able to choose which folder you want it to be. And if you click here and set as working directory, you'll get this little code that I like copying into the very top of my codes while I'm working on them, which basically is going to tell R to which folder do I want to go and in which folders my files are going to be in the beginning of this project. So in this, I'm going to be working with the chicks weight dataset, which is basically a dataset that's already in R, embedded. And I'm going to assign it the name of chicks just so it's shorter for me. Chick weight. There we go. So if you see here in my variables, I now have a variable chicks, which is a date table with 178 observations of 4 variables. You can see it right here. So we go back to the text editor. Let's start with the measures of central tendency. So the mean is very, very easy. Okay, so actually let me first show you the structure of chicks. Chicks is a data set and it has 4 columns: the weight, time, chick, and diet. The weight is numeric as well as time, and then the chick is an ordered factor, which means categories that are in order, like extremely dissatisfied to extremely satisfied. And then the diet is a factor with 4 levels, which means it's a factor with 4 categories. We can also get an overview by using summary. And this overview will give us as well so you can see the output. This overview will give us as well the minimum and the maximum of the numeric variables. And for the factor variables, it will let us know how many observations are in each factor. So we have 220 observations of chicks that were on the first diet, and for example 118 observations of the chicks that were on the 4th diet. So if we start now with the measures of central tendency, calculating the mean and the median is very easy on R. You just put mean of chicks, and in this case I'm going to select the column weight by putting a $sign and then writing weight, and you'll see that the mean is around 121 grams, I guess. We can also calculate the median on the very same way. And the median is 103. Another thing we can calculate is the mode. However, R doesn't have a mode function per se, at least on its basic package. So if I write mode of chicks weight, I'm not going to get the mode. There's a couple of ways to obtain it. My favorite one, or the one I use a lot, is Wix Max and then Tabulate, chicks weight, and it's 41. So just so you get a grasp of what this tabulate function does, I'm going to run this first because it was not on the video. So it's 41 here. So what Tabulate is doing is giving us an overview of how many observations are in each value. So it starts, in this case, it starts by 1. So there's 0 observations of the item 1, 0 of the item 2. There's 1 observation, and this should be the minimum. So if we just write min chicks weight, we see the minimum is 35. So there's 135 on the data. There's no 36, no 37s. And around the 41 one, we get the week max. So that's the 41st value who has 20 observations. So this is how you get the mode, and this works for unimodal datasets. We move on to the measures of variability. The standard deviation and the variance work very similar as the mean and the median. So we just wrote SD of chicks and select the column weight. And the variance works more or less the same. Variance of chicks, and we select the column weight, and I'm pressing Ctrl Enter to just run my code. And you'll see that the standard deviation is 71 and the variance is 5051. Another very important measures of variability are the quantiles or the quartiles. And the most important ones are the quartiles, the Q1, Q2, and Q3 we have. Okay, so if I show you a distribution of this variable, basically it's telling me that 25% of the observations fall below this value, which is around 60 something. 50% of the observations, that means like they fall under 100 and little thing. It's around, in just 1 second, less than 103. So that's also the median. The quantile 2 is the median, and the quantile 3 indicates how many observations are below, is which number is bigger than 75% of the observations, and that's the 75% quartile. So basically they are a good indicator of, where most of our observations lie, in which areas, and it's just always a good thing to have. So if we go back to our data, to calculate the quantiles, we can just use the quantile function. So quantile chicks, and I'm going to clean this. So you'll be able to see that the minimum observation is 35, 25% of the observations fall under 63, 50% of the observations fall under the 103 grams, 75 of the observations fall under 163, and the maximum observation is 373 grams, I guess. And one last thing before we end up this, how to deal with NAs. Right now I introduce an NA, so like an empty value of my data. Chicks, let's put the first one. Chicks 1, it's NA. So the first row, the first column, I'm just going to make the first value NA. And now I try to do mean of chicks weight. We'll get NA instead of the mean. And this will happen with most of the other functions that we've seen as well. And the easiest way to deal with this in this case is just to remove them from our calculation. And for that, we're going to use the na.remove variable. And we're going to set that to true. And we'll see that it still calculates the mean. It will ignore those NAs. So you will have less data when computing the mean, but it's still a very good way of achieving this kind of univariate analysis while not overcomplicating your life by trying to find other values to replace those NAs. I hope this was useful. I will leave some notes on the comments on the video, and I'll see you in the next video.